Hi folks, so today we're going to talk about position and velocity and acceleration. So three key vocabulary terms when we're talking about kinematics. We're going to talk about what they mean, and we're going to try to demonstrate them with the use of the cart and the cup and the track here, and also with the use of a motion sensor that's connected to the cart. So first thing is just reviewing our key vocabulary. So talking first about position. So position is just what is the object's location with respect to some frame of reference or some origin. So for a visual, let's use this red cup as our frame of reference or our origin. So right now, the cart's position is it's about 0.5 meters to the right of the cup. If I move the cart to a different spot, now it has a different position. So now its position is about 0.9 meters to the right of the cup. Obviously, we could also be on the left side of the cup, and we could talk about that. So we could say positive direction for position, positive or negative direction for position, to the left of the cup or to the right of the cup. So the positive or the negative, when we're talking about position, tells me, are we to the right of the cup or are we to the left of the cup, or whatever that origin might be. It doesn't have to be a red cup. That's just a marker for us. So whatever is your frame of reference that you're measuring from, that's how we describe position relative to that marker. Okay? So next is velocity. And velocity tells us how fast an object is moving and also in which direction it's traveling. And it's very important that you pay attention to both of those pieces of information. So it's not only how fast is it going in meters per second or miles per hour or kilometers per hour, but also which direction it happens to be traveling. You need both in order for it to be velocity. So in our example here, when the object is moving in this direction, we would say that it has positive velocity. And when it's moving in this direction, we would say that it has negative velocity. And then how fast it's going tells me what that number is. So if it's going slowly to the right, it's going to have a small positive velocity. So it might be 0.2 meters per second in the positive direction. If I take it and move it much faster that way, like this, then we could say, oh, the object has a velocity of 3 meters per second in the positive direction. So it's moving much faster in the positive direction. Okay, right now I'm calling to my right positive, to the left negative. Okay, so if the cart moves in this direction, I would say it has a small negative velocity, so maybe negative 2 meters per second. Okay, if we move it to the left and move it much faster, now we might say, okay, its velocity is negative 3 meters per second or something like that. So moving to the right or moving to the left tells me the velocity is positive or negative, and how much velocity is how fast that thing is going. So that's the magnitude. Okay. Lastly is acceleration, and acceleration tells us about how rapidly an object's velocity changes over time. Okay, so keep in mind, if an object is moving along in a straight line and not changing its speed at all, it's not going to have any acceleration because it's not changing its velocity. It's not changing direction. It's not changing speed. But if the object speeds up or slows down or changes direction, then it's going to have an acceleration. Okay? One of the things that will be helpful to you to think about when you think about acceleration is the acceleration is always in the same direction as the net force that's acting on something. So imagine this. Imagine that this cart is coasting along and there's friction. So as it coasts along, it slows down and stops. Well, think about that. It's slowing down and stopping because there's a force acting in this direction. As it rolls this way, there's a force working against it. So the acceleration is in that direction, opposite the velocity. On the other hand, if I took this cart and continually pushed it and pushed it and pushed it and pushed it, it's moving to the right, and it would be getting faster and faster and faster. Why? Because I'm pushing it this way. The acceleration is in that direction. Okay? And a rule that's helpful for this is if the velocity and the acceleration are in the same direction, then the object has to be getting faster. And when the velocity and the acceleration are opposite directions, that's when the object is slowing down. So it's an easy way to kind of remember how velocity and acceleration would be related to each other. But let's look at this graphically. So I'm going to place the cart at a particular position and just leave it there. So its position isn't changing. There's a sensor inside here. I can click collect, and we'll be able to see it on the screen here. And what we can see is that the object's position is somewhere between 0.6 and 0.8 meters from the cup, and it's not changing at all. Its position hasn't changed. If I put it in a different spot, so I place it here, hit it again, now you'll notice its position is below 0.6, so it's closer to the cup than it was previously. Okay, so position is just telling me where the object is. So think about what happens if I start the object near the cup and I allow it to roll in that direction. We should see the position changing. So if we watch, we can see how the position increased over time, and you can see it increased very consistently there. So think about what that means. It was moving at a consistent pace in this direction. We could say the object has a positive velocity, a positive constant velocity, in fact, because this line is straight. It's not a curve or anything like that. Okay. If I hit it and move it in this direction, in this case, we could say the object had a negative constant velocity. It was moving in the negative direction, and it was moving consistently the whole time, same speed, up until the very end when I put my hand on it and stopped it. Okay. So let's look at what it looks like when the object accelerates. So if I continually push the cart, let's say, so if I did something like this, okay, you'll notice that the position versus time graph now has this curve. This is because in the beginning it wasn't moving very fast. It wasn't changing its position very much. But towards the end it was changing its position more rapidly. So we have a curve, and that curve on a position versus time graph tells me that the object is accelerating. Let's talk about velocity and time, though. I'm going to switch this graph over and make this a velocity versus time graph instead. So we're going to change it to velocity. Okay, so now it's going to track velocity instead of position. So if I leave it alone, do nothing, hit collect, you'll notice that the velocity is showing up right on 0. Well, think about why. If velocity is how fast and what direction something is moving, it's not moving at all. It has 0 velocity. It's not moving to the right, it's not moving to the left. Okay? Now, as I take the cart and I move it to the right, watch what happens. Up until it bumped into the bumper, you'll notice the velocity was staying around the same value. It's actually decreasing very slightly. There's a little bit of friction between the cart and the track, so the cart does slow down a little bit, but overall, the velocity of that cart was about positive 0.4 meters per second as it was rolling. So it was moving across to the right at a pretty consistent pace, slowing down just slightly. If we push it in the other direction, now you notice the velocity is actually negative. All right? Our velocity was about negative 0.4 and some change meters per second. It was moving to the left, the opposite way. So that's the reason why the velocity is negative. It's moving the opposite direction. Okay, so when it's moving in the positive direction, it's going to be up here somewhere on the graph for velocity. When it's moving in the negative direction, it's going to be down here somewhere because it's moving opposite way. Okay, so if I do one where I change the direction somewhere along, so if we have it going this way, and then stop and come back, you notice that the velocity went from being positive to eventually being negative. It was moving in the positive direction at first, and then it changed direction and it went in the negative direction. So I just wanted to give you some visual and some information to help you understand what position, velocity, and acceleration were, but also to understand what they look like in terms of a graph. So hopefully this was helpful to you.